All right, so here we are with our last section from chapter 11 on volume. Then we're talking about spheres, which are basically circles. All right, so three-dimensional circles. So our objectives are to learn and apply the formula for a volume of a sphere, and then also learn and apply the formula for the surface area of a sphere. So before we get started, we want to double check that we know what a sphere is. It's the locus of the set of points in space that are a fixed distance from a given point. So here we are with our given point. And then we have this center that then has all of these points in 3 dimensions, the radius length out from there. We also have our definition of hemisphere. That's this shaded area right here. It's half of the sphere. We're talking about volume. And then it could also be surface area, which would be just, again, half of that. And then there's a great circle, and the great circle divides a sphere into 2 hemispheres. So it's kind of like the equator. All right. So the first thing that we have then to write down is our volume of a sphere. So here we are with the volume of the sphere. It's 4/3 times pi times the radius cubed. So as long as we know the radius, we can go ahead and find the volume. All right, so our first example here, looking through this, is to find the volume of the sphere, and we need to give our answer in terms of pi. So our volume is, again, 4/3 pi r cubed. Yep. And our radius is 9. So that means that we're going to fill in 4/3 pi 9 cubed, which is going to get pretty big. And notice that it says to give your answer in terms of pi. So technically, we're going to take 4/3 and multiply it by 9 to the third, and then keep that pi afterwards. So 4/3 times 9 to the third, let's see. Leaves you with 972. So we have 972 next to a pi, and we are given centimeters, and then it is volume, so cubed. All right. Then we have our next example, which is to find the diameter of a sphere with a volume of this. And so we're going to use that volume formula to solve backwards in order to get the radius and then double it because we want to get diameter. So again, volume is 4/3 pi r cubed. But we've already said that our volume is 972 pi. So instead of a V, we'll put 972 on this side. And then 4/3 pi r cubed on this side. Then to solve to both sides, at least to start out to get rid of some kind of ugly looking things, we're going to take out the pi. So both of them will have a pi that is taken away, and so 972 equals 4/3 r cubed. So then there's a few ways to solve this next one, but the easiest way for me at least is to multiply by the reciprocal. So we're going to multiply 4/3 times 3/4, which will cancel it and leave you with r cubed. But then over here we're going to multiply by 3/4, and so we need 3/4 of 972. And so we get 729. Then we have something cubed, and so to undo a cube, you're going to take a cube root. You could also, because it's going to be a whole number, ask yourself what times itself 3 times makes 729. But you can also go into your calculator, into the math key over here. And so all those buttons that are given on the home screen here or on the face of the calculator, there are extras that are in the math. So in your math key, notice that you have a cube that's not on here, and you also have a cube root. So if we go down to number 4, press enter, we're going to take the cube root of 729. So the cube root of 729 is 9, which means that our radius is 9. But of course, we're going to multiply that by 2 because we want a diameter. And so your diameter is 18. And looks like we were given inches, so that's our units. All right. Next example Talks about a hemisphere, and again, remember a hemisphere is half of a circle, so we just need to do, the half of the sphere. So we just need to do the volume formula for the sphere total and then divide by 2. So the first thing here is, again, it's volume divided by 2, but volume is 4/3 pi r cubed. And again, we'll divide that result by 2. So plugging in what we have a radius of 4. So our volume of the hemisphere is going to be 4/3 pi 4 cubed, and all of that divided by 2. Notice that again it says in terms of pi, so technically we can just do 4/3 times 4 to the third, all of that divided by 2, and then this pi can be out to the side. So if we evaluate 4/3 times 4 cubed, let's see, 4/3 times 4 cubed is 85.3, and then divided by 2. So we're going to get 42.6 repeating, and then a pi. So again, this piece right here was this. All right. Then the next thing is surface area. We haven't talked about a surface area a whole lot, but basically if you covered this sphere with paint or something, you would want to know how much of the surface there is so that you can find out how much paint to buy. Or if you were wrapping it in saran wrap or whatever it happens to be. So great examples. So surface area of a sphere formula is S for surface area and then 4 pi r squared. Because remember that surface area is in 2 dimensions, so we are going to have a squared versus our volume, which had a cube. So trying to apply this formula, we're supposed to find the surface area of a sphere with a diameter of 10, but of course that's tricky because they want you to hopefully find that the radius is 5. So our surface area is going to be 4 pi r squared, but our r is 5. And then notice it says in terms of pi, so we can rewrite this as 4 times 5 squared times pi, so that we can just evaluate 4 times 5 squared. And 5 squared is 25. 4 times 25 leaves us with 100 pi. And then from there, we're going to put in our units, which are feet, and then of course it's area, so feet squared. That's the surface area, given the diameter. The next one needs to find the volume with the surface area here. So we're going to use this to work backwards to find our radius and then plug it into our volume formula. So we know that surface area is 4 pi r squared, but we also know that the surface area is 144 pi. So we'll take 144 and plug it into the S. And 144 pi, sorry. And then as we did in the previous problem, we'll go ahead and divide out the pi first. Kind of leave us with regular numbers. So pi's cancel, and we're left with 144 equals 4r squared. To solve this, we'll divide both sides by 4. Thinking of the order of operations backwards, so we're doing SADMEP. And so we will be doing multiplication before we do powers. All right, so 144 divided by 4 is 36. So we're left with 36 equals r squared, and then of course the square root of 36 leaves you with 6. That's not quite the end of the problem, because now we're going to use those results to find the volume. So the volume is 3/4 pi r cubed. And by 3/4 I mean 4/3. Got that flipped. And then we'll plug in the r that we just solved for, which is 6. and rearrange so we just have the numbers and then the pi. So we're going to get a pi at the end of this decimal. So 4/3 times 6 cubed. And so we get 288 pi. We also have a unit, which is meters squared. And since we're doing volume, we're going to do meters cubed. All right. And moving on to our last 3 examples. In this one, we want to find the surface area of a sphere with a great circle that has an area of 4 pi inches squared. So in this case, the great circle meaning the equator, but we're talking about that kind of surface that would be at the equator. So in that case, we have an area of a circle, which is pi r squared, but then also the fact that the area equals 4 pi. So that means that we need to solve in order to get this new area, or sorry, this radius. So 4 pi is going to equal pi r squared. To both sides, we'll divide out that pi and be left with 4 equals r squared. And then, of course, square rooting both sides leaves you with a 2 for your radius. So now that we know that 2 is our radius, we can go ahead and find the surface area, which was 4 pi r squared, and plug in our r of 2. So 4 times pi times 2 squared. But again, rewriting it so that we can just do the numbers first and then have a pi for terms of pi. We're going to do 4 times 4 in this case, so 16 pi, and then our units are inches and then cubed since it's, oh wait, squared, because we're doing surface area. All right. This next one here kind of references this idea of changing dimensions that we've talked about before. So if you remember in the past, if you had the 1 dimension in order to get to 2 dimensions of a measurement, you're going to square. But if you have 1 dimension and you're trying to get to 3 dimensions, you end up taking the thing that you are doing and cubing it. So in this case, the radius of a sphere is tripled, meaning the length or the 1-dimensional idea is tripled. So if we multiply by 3, tripling that radius, we're actually multiplying by 3 squared if we were going to talk about how it changes the area or the surface area. But we'd multiply by 3 cubed if we're talking about how it becomes a 3-dimensional shape, which is this volume. So the 1-dimensional or the length is multiplied by 3. The 2 dimensions then is multiplied by 3 squared, but that's not what we're looking for. And the 3 dimensions then would be multiplied by 3 cubed. And so the effect of the volume is that the volume will be increased by a factor, meaning multiplying, of 27. Given when the radius is tripled. Oops, is. All right, then our last example is about a composite figure. So it just means we're taking this cone, putting it together with this hemisphere, and trying to figure out what the volume is in this case. So the total volume is going to come from taking the hemisphere and adding it to the cone. So we've got a cone here, hemisphere on top, a little ice cream cone looking thing. So the volume of a hemisphere is going to be our volume equation, so 4/3 pi r cubed, but then remember divided by 2 because we're talking about half of the sphere's volume. And then a cone, going back to our previous lessons, is going to be the volume of 1/3 pi r squared. Oh, and then height. Okay, there we go. Missing a piece there. Okay. So filling in what we have here, the radius is said to be 7, so we can go ahead and plug in a 7 right there, meaning we have 4/3 pi 7 cubed over 2. It does say in terms of pi, so we're just going to go ahead and take out that pi and evaluate the other pieces. And so evaluating the other pieces leaves us with the multiple of 4/3 times 7 cubed. So 4/3 times 7 cubed, and all of that divided by 2. So again, depending on what order of operations you do, and hopefully you do the correct one, I did 4/3 times 7 cubed, and then took that value and divided by 2. So we're going to get 288.6 repeating as our volume of the hemisphere. For the cone, we're going to get 1/3 pi, radius of 7, and height of 25. And again, we're going to try to evaluate that without having the pi involved. So if we take the pi out back here, we're going to get a value in the front of 1/3 times 7 squared times 25. And so we have 400.3 repeating as the volume of the cone. And so now we're going to put these two together in order to get the total volume. And so putting them together leaves us with, well, that's interesting, 289. So, sorry, 600. Hello. So 689, and of course pi is tacked on at the end. So 4 and 2 make 6. 88 plus another 1 from 0.6 repeating and 0.3 repeating. 689 pi, and then our units for volume are centimeters and then cubed.